Morning grade 10. Let's see a very important theorem from topic 3, and that is tangent segment theorem. Now see students, this is a circle with center O. Point P is in the exterior of the circle. From point P, you can see there are two tangents PQ and PR. Now what is the theorem? If you are drawing two tangents from one external point to the same circle, then those two tangents are always congruent. See the statement? Tangent segments drawn from an external point to a circle are congruent. Now what is given? A circle with center O is given. Lines PQ and PR are tangents to the circle at points Q and R respectively. That means Q is point of contact and R is point of contact of these two tangents. And what we have to prove? That segment PQ, which is a tangent, is congruent to PR. So these two tangents which are drawn from the external point to the same circle are congruent. That is tangent segment theorem. Proof is also very easy. Now consider what construction we have done. We have joined this OP, OQ and OR. Why I have shown this 90 degree? It is due to tangent theorem. See, earlier what we have seen? Tangent theorem. And this is what? Tangent segment theorem. What is tangent theorem? Tangent is perpendicular to the radius. That is tangent theorem. Alright. And what is tangent segment theorem? Two tangents drawn are congruent if they are drawn from the same external point to the same circle. Are you getting the difference? So we are using tangent theorem to prove tangent segment theorem. So I have shown here 90 degree angle. Now consider these two triangles. Which two triangles we are considering? OQP is first triangle and ORP is second triangle. So we have considered these two triangles. This is triangle 1 and this is triangle 2. Now what can you see? Say in these two triangles, this is angle 90 and this is angle 90. Why 90? Tangent is perpendicular to the radius. We have seen this in tangent theorem. So I have written here tangent theorem. This is 90, this is 90. Opposite to 90 is hypotenuse. So OP is hypotenuse and it is common side. Are you understanding me? So OP is common to both of these triangles and OQ and OR both are radii. They are equal. So in this first triangle and second triangle, one side and hypotenuse of one triangle is congruent to other side and hypotenuse of the other triangle. Therefore these two triangles, so I am showing these two are congruent because they are radii and hypotenuse is common. So first triangle and second triangle are congruent by hypotenuse side test. Once these two triangles are congruent, PQ and PR are corresponding sides of congruent triangles. So once the triangles are congruent, we can write PR is congruent to PR is congruent to PQ or PQ is congruent to PR because corresponding sides of congruent triangles are always congruent. And what are PQ and PR? They are tangents. Very easy proof, no? Only we have to use hypotenuse side test. Okay, so please remember two theorems. First is only tangent theorem and another is tangent segment theorem. Problems will surely come and you should have the habit of writing theorem also. In your question 3B, one theorem is likely to come. And how to write a theorem? Without diagram you will not get a single mark for theorem. So you have to write first statement, then you write given, then you write what is to be proved. If there is some construction you mention and then write the proof. Alright. So let us see few problems related to this tangent segment theorem. So let's start with exercise 3.1. This is your first problem. In the adjoining figure, radius of a circle with center C is 6 cm. So radius they have given as 6 cm. Line AB is tangent to A. Can you see this line AB? So this is tangent to the circle at point A. Answer the following questions. So I have just joined this CA and CB. Alright. What is the measure of angle CAB and Y? CAB. What is this measure? So it goes without saying. They have already given AB is tangent. Yes or no? AB is tangent and CA is radius. We know that tangent is perpendicular to the radius by tangent theorem. and therefore perpendicular means it measures 90 degree, and therefore CAB is equal to 90 degree. I have written all the steps. You can pause the video and write it down, but first listen to the explanation. Question 2. What is the distance of point C from line AB and Y? So distance of this C from AB. Whenever any distance is asked from a particular thing to a point, it is always a perpendicular distance. Okay? AB is tangent and CA is perpendicular by tangent theorem, and it is already been given that radius is 6 cm, and therefore C is at a distance of 6 cm from line AB. Alright. Question 3, you see distance AB now they have given as 6 centimeters. I should be writing cm over here. It is given as 6 centimeters, and then you have to find distance between points B and C. Now see, this is already 90 we have proved by tangent theorem. So CAB becomes right angle triangle. We can apply Pythagoras theorem into it. So applying Pythagoras theorem in this triangle, hypotenuse is CB or BC. So BC square will be AC square plus AB square. So BC square will be 6 square plus 6 square. 36 plus 36. It becomes 72. But we don't want BC square, we want BC. So what is BC? Square root of 72. That is square root of 36 into 2. Square root of 36 is 6. So you get answer 6 root 2 centimeters. What is measure of angle A, B, C and Y? Now look at angle A, B and C. Now see students, if you look carefully, AB is also 6 and CA is also 6. So these two lines are equal. These two lengths of the triangles, sides of the lengths of the triangle are equal. So this triangle automatically becomes isosceles triangle. This is 90. We know that angle opposite to the congruent sides are also congruent. So angle opposite to this is angle B. Let us say it as X. Angle opposite to AB is C. Let it also be X. Why both are X? These two sides are equal, and therefore angle opposite to congruent sides are also equal. Now this is 90, this is X and this is X. So what we have? X plus 90 is 180 degree. Angle sum property, sum of all angles of a triangle is 180 degree. So X plus X is 2X. 90 shifted over here, you get 180 minus 90. So 2X is 90, and therefore X will be 90 upon 2, which is equal to 45 degrees. So this also you got 45 and this also you got 45. So it is isosceles right angle triangle, and therefore measure of angle ABC is equal to 45 degrees. Very easy. Okay. So please take it down. Alright. Let's go to the next problem. Now look at question number 2. This is second question we are doing. In the adjoining figure, O is the center of the circle. From point R, segment RM and RN are tangents. So O is center, RM and RN are tangents, touching the circle at M and N. Okay. Further, if OR is 10, OR is given as 10 centimeters and radius of the circle, radius is given as 5 centimeters. Then first question is, what is the length of each tangent segment? So this is 5, this is also 5 because both are radius. So this is also 5 and this is also 5. So first they have asked what is the length of the tangents. Now see, in this triangle OMR, angle M will be 90 degree by tangent theorem. Radius and tangent are perpendicular. That is the tangent theorem. If this is 90, we can apply Pythagoras theorem in this triangle. Opposite to 90 is OR. So we have OR square is OM square plus MR square. OR square is OM square plus MR square. So 100 square will be equal to 5 square plus MR square. If you solve this, we get 100 minus 25, which is equal to MR square. So what is MR square? 75, which is 25 into 3. So what is MR? Which is equal to the tangent. MR and RN, both are tangents, no? And they are congruent as per tangent segment theorem. So we have MR is equal to root of 25 is 5, so 5 root 3. So I have written here MR, which is equal to NR is equal to 5 root 3. Why both are equal? It is according to tangent segment theorem, that tangent drawn from the external point are congruent to the circle. Now second question they have asked is, what is the measure of angle MRO? Can you see this MRO? This angle they have asked students. This angle. Now carefully observe this triangle MOR. This is 90, this is 10 centimeters, which is opposite to 90-degree angle, and half of 10 is 5 centimeters. If this is right angle triangle, we know that in a right angle triangle, side opposite to 30 degree is half of the hypotenuse. So in that sense, if this is 10 and this is 5, side opposite to this is the side which is opposite to angle MRO, and that is half. So MRO becomes 30 degree. This is your 30, 60, 90 degree theorem from 9th standard if you revise. Okay, in a right angle triangle, or in a right angle triangle where measures are 30, 60 degrees, 30, 60 and 90 degree are the measures of right angle, then as per 30, 60, 90 degree theorem, side opposite to 30 is half that of the hypotenuse. And therefore, we have this as MRO is 30. If this is 30, this also will be 30. And what is this big angle? MRN they have asked. This whole is addition of this angle plus this angle. This is 30, this is 30. So, this becomes equal to 60 degrees. I hope it is clear. Please pause the video and take down all the steps. So, that's all for today. Thank you.